Hello students, welcome to this lecture, and in this lecture we are going to see some important formula of differentiation which we will be using in various questions of calculus in physics also and obviously in maths also. So basically the formula which we studied earlier, if you remember that formula, the differentiation of x to the power n, this is nx to the power n minus 1. For any n, this is the formula which we have. Now we have some other formula also, like if we want to find the differentiation of e to the power x, then that is actually e to the power x only, and e to the power x is the only function which when differentiated gives the same function, and also when it is integrated it also gives the same value, because the inverse process will also give the same result. So this is the second formula. There is a change here. If there is kx over here, then what we will do? Then we will get k e to the power kx. So the coefficient of x will come here. This is basically from chain rule. We will see this rule also in the next lecture, which is about rules of differentiation. Right now we are seeing formulas of differentiation. If we say a to the power x, then what is its differentiation? A can be any positive number. Obviously we don't take base as negative and 0, and 1 also, not 1. So we can here write a is greater than 0 and also a is not equal to 1. In that situation we get a to the power x log of a. And in calculus generally, if we are not writing any base over here, that means the base is e. So we can write it like this also, or we can simply write it as log a, or we can also write it as ln a. So all of these mean log a to the base e.
This is also called natural log.
This is also called natural log. Basically two logs are more famously used. One is the natural log and another is the common log. And you can make many other logs, but these are more commonly used. In natural log, you take log x to the base e, and in common log, you take log x to the base 10. So basically, when we take only log x or we take ln x, that generally means that we are talking about the natural log in calculus mostly. So in calculus, log x to the base e or log x or ln x, everything means the natural log. And further we can also find the formula for differentiation of log of x. Again natural log this is, which you can also say differentiation of ln x. This will come out to be 1 by x. Then further we have a formula, the differentiation of log of x to the base a. Again a is having this same condition along with this. It can be 2, it can be 3, it can be half, anything which is greater than 0 but not equal to 1. So when this will be differentiated, you will get 1 by x and log a in the denominator, natural log. So these are some of the formula which we see in action.
Have more application in physics. So these are common things that students come across the application part of physics.
Other than these, we have set of some trigonometric differentiations also. So let us see those also. So here you have 6 formula which you have to remember. You can do one thing, you can take the screenshot of this frame and you can take a printout and just paste it where do you study, at your study table, and you can learn this formula automatically with time. So this is the best method which we also used to do in our time. So this is the best method for you also. Next is the set of trigonometric formulas which generally is used in physics. So 7th formula we take as differentiation of sine x, which is actually cos x. 8th is differentiation of cos x, which comes out to be minus sine x. Next is differentiation of tan x, which comes out to be sec square x. Then we come across differentiation of sec x, which comes out to be sec x into tan x. Then we have differentiation of cot x with respect to x, which comes out to be cosec square x
minus
cosec square x. And then we have differentiation of cosec x with respect to x, which comes out to be minus cosec x into cot x. So these 6 trigonometric formulas are also most important. Then we have some inverse trigonometric formula also, but we won't do all of them. We will do only one. That is, basically, if we differentiate sine inverse x with respect to x, we get 1 by root over 1 minus x square. And there is one more formula, that if we differentiate sine inverse x upon a, in that case we get a formula 1 by root over a square minus x square. Again, if you know this, you can easily find this by chain rule, which we will study in the rule of differentiation
in the next lecture.
So I think, can we give a different derivative of any of this like we did in previous class of
Yes.
x to the power n?
Yeah, we should give some problem, so that, because these formula can be best learned if you practice some problem based on this formula. It is not that you have to just learn this formula by rote learning, but just by going through few problems, you can apply this formula on those problems and you will automatically learn in the process all this formula. One important thing that I can notice from this formula is that whenever there is c here, that is cos x, cot x and cosec x. So in all the 3 cases, the differentiation comes out to be negative. So this is how I used to remember, because sometimes I get confused. When you learn integration, you will get the reverse value of this. So just to remember this, I have a technique that whenever I have c here, the value come out to be negative, and other cases the differentiations comes out to be positive. So we can give a few questions.
Yeah, sure.
For a student to solve.
You can.
So if let us say a function f(x) is given, and let us say the function is 1 plus cos 2x, let us say. So how you can solve this differentiation? So I can think one more formula we should give that.
Yeah.
To differentiate a constant function, and if k is given in the sine or cos.
I think it would be better if they attempt this question after the next lecture, which is about rules of differentiation, because this was about formulae of differentiation. So we have right now formula of differentiation with us, but many times we won't feel satisfied on applying any formula, but we need some rules also along with it. So we need to know the rules of differentiation also. So basically these are the formula which we will obviously learn, and many places you can directly apply them, but at many places you need some rule also, because this is a question where you see that there is a cos 2x function. It is not simply cos x. So what is the difference when instead of cos x you get cos 2x? So yes, this is a point to ponder about, and this is your task. Now there is all the facilities you can use and think that what we should do in order to differentiate it. But we will discuss the same question in the
case they are not able to understand. Anyway, we are going to explain the concept that it will help you solve this question. So
let us have a break for the next lecture, and you will continue with the same concept in the next lecture. Thank you, students.
Thank you.